Hello students, today we are going to discuss about fluid. Fluids are basically, these are the material or these are the substances which easily deforms, okay, and the deformation is continuous with the application of the shearing stress. You know that if you consider any kind of solid, okay, like copper or rubber, you can understand that whenever you apply the shearing stress or the normal stress, in all the cases the deformation occurs, okay, but when you remove that, or if you keep on the deformation is not it is not going to continue for an infinite amount of time, because in case of solid, what happens, if you consider these molecules, okay, if you consider the molecules like that, as I have already discussed in the initial video, like that, you may remember the molecules are attached to each other like this, isn't it? So in case of liquids, solid, what happens, this attachment is very strong, okay, intermolecular force is very strong, as a result of which if you apply, okay, deforming force on it, it takes lot of time, deforming force on it to take lot of time to deform it, okay, and you can deform it only up to a certain extent. It cannot be continuous. But in case of fluid, what happens, the intermolecular force that is holding the molecules is not that much strong. So you know that you can give any shape to the liquid, isn't it? Any kind of pot you have, any kind of vessel you have, you can put the liquid into it. So that means you can deform the liquid to any shape in any form continuously whenever you apply a stress, okay, deforming force or deforming force or deforming stress. So if it is a fluid, so that is why a fluid is basically defined as a substance that deforms continuously when acted upon by shearing stress of any magnitude. Like here, what happens, if it is a solid, okay, if it is a solid, then what happens, that if you want to change the form of this particular solid, what you need to do, you will have to keep on applying the deforming force, okay. So only after a certain deforming force you can change it. Suppose if you have a steel wire, and if you want to extend its length, so if you give 5 kg, it may not change. If you give 8 kg, it may not change. If you give 10 kg, then only it will change, okay. So there are certain kind of limits, and that up to 8 kg it is not going to be affected. Only after 8 kg or 9 kg it is going to be affected. But in case of fluid, what happens, whatever magnitude you are applying, it will show some kind of changes. That is the difference, okay, between fluid and solid. So fluids are basically include, all of you know, this includes basically liquid and also gases, okay. And here we need to take two things in consideration. First of all, we will say density, okay. I will give some preliminary information. Density, we need to care about density. Now density, you know that it is basically mass per unit volume, isn't it? So this is one specification that we also always need to carry about this fluids. Next thing is viscosity, okay. I hope you have already studied about viscosity. Still I will talk about it here. See, viscosity is basically what, as I told you, that suppose that there is a box, okay, and it is kept on a floor, fine. So there is a contact between the lower surface of the box and the floor, and because of which what happens, there is a frictional force between them, isn't it? Because of which the box is staying stable on the floor. Similarly, where we are walking, suppose somebody is walking on the floor, okay, so his feet is in touch with the floor, and there is a frictional force, and that's why you can stand up on the floor. Similarly, I am holding this pen, there is a frictional force between this pen and my fingers, that's why I can hold. Otherwise it will slip away, we can't have grip on anything, we can't, so we will always fall down. So it's like friction is kind of necessary evil, okay. So so similarly, liquids, suppose that whenever liquids are there, suppose this is a river, okay, this is a river bed, and this is water is flowing like this, understood? So what happens, basically water will form different layers, okay. This is a river bed, Okay, the bottom or river bed, or you can say bottom. Okay, and this is the uppermost surface. Okay, this is a river. Now when water is flowing, what happens? The water layer which is in contact with this particular bottom is steady. Okay, the velocity here is zero. Okay, this water layer at contact with the bottom is at rest. Okay, this is at rest, and slowly what happens, this layer the velocity is slightly increasing, here the velocity is slightly increasing, here increasing, and maximum velocity the water, as you have seen that if you see a flowing river, you can see that the uppermost layer water is flowing very fast, but that doesn't mean that the water inside also flowing in the same level. Understood? So if the water is flowing that much fast, it will be lower, the velocity will slowly decrease, and it will be zero at this point. Understood? So this is, suppose here velocity is 0, if I don't take the numbers very seriously, but definitely it is 0 here. Similar, next it is 2, next it is 3, 4, and this is 5 is the maximum the open this free surface. Now you can see that why does it happen? Because the water basically flows in different layers. It is not a single layer. The water molecules actually each water molecule applies some frictional force on the other water molecule. Okay, as a result of which what happens, a particular layer of water applies frictional force on the another layer of water. So in that way what happens, this layer, see, this bottom layer is on this side it is contact with the bed, okay, or bottom, and on this side it is contact with this layer 1, so its velocity is 0. Similarly, if it goes up, this is slightly moving, so its velocity is slightly increasing, and maximum, because upper face is free and lower face there is a friction, so the uppermost face is getting layer is getting friction from inside only, not outside, so it is having the fastest velocity. That means you can get to know that as solid things apply frictional force, liquid also applies frictional force. Okay, liquid and gases, and that happens in this way. Every liquid or fluid you can consider to be formed in a particular layers. Okay, and each layer tries to reduce the relative velocity. Okay, so that particular property is called viscosity. Means viscosity. So this is why that means this layer is trying to reduce the velocity of this layer, this layer is trying to reduce the velocity of this layer, so this particular property is called viscosity. Okay, so viscosity is a kind of frictional force. Okay, is a property of what a fluid, by virtue of which the fluid tries to reduce, okay, the relative velocity between the liquid layers or fluid layers. Okay, so that particular thing is called viscosity. So it's a kind of frictional force. So while studying about fluids, we need to take care of this thing also, viscosity. That I will discuss in detail, but for preliminary discussion also we need to think about viscosity. And next is called bulk modulus. Okay, that thing we need to take into consideration. And why is it like that? Because you know that bulk modulus is basically related to what? Normal stress divided by volumetric strain, isn't it? So basically it is about change in the volume. So it is said that liquids should have ideal fluids. Okay, we for all the kind of discussion that we are going to do here will be about ideal fluids. Okay, so ideal fluid means what? It has zero viscosity. Okay, and next thing is that it should have infinite bulk modulus. What does it mean? I will tell you. This should be infinite. This is infinite means what? This should be 0, isn't it? If denominator is 0, the whole thing will, denominator is very small, then it will be infinite. So volumetric strain should be almost equal to 0. Volumetric strain equal to 0 means what? There cannot be any change in the volume. Okay, so that means under any condition ideal fluids cannot be compressed. Okay, so what does it mean? Infinite bulk modulus means incompressible fluid. Okay, That means change in volume is 0. Next thing that we need to discuss about fluids, these are all preliminary conceptions, so these are not the original derivations that we are doing. Let's say that is rate of flow of liquid, okay, or rate of flow of fluids. So for that we need to for this particular thing we need to arrive at a particular formula, okay, or particular expression. For that, what we are considering, suppose I am considering a tube, okay, tube like this, and water is or I will not say water, but a kind of fluid is flowing through it, okay. So suppose that fluid is flowing through it in this particular direction as I have shown by this arrow, okay. And what I will consider in this particular whole tube, I will consider two sections, okay, like this. This is one section, that is A, and another section, that is B. Fine. And liquid is flowing out like this, okay. And suppose that this distance between section A and B is equal to, say, small l, fine, and this particular area of cross section, that is equal to small a, fine, and this is small l. And suppose that the time taken by a particular liquid, suppose there is a liquid molecule which has reached section A, fine, and this is section B. A liquid molecule has reached here, okay. So it will take to reach here, okay, to reach here this liquid molecule will take time small t, all right. So and so what we can infer from this is that, suppose that the molecule is flowing from here to here, and it has taken time t, and the distance is l. So you know that distance divided by time is nothing but what? Velocity, okay. So distance is what? L, time is t, this is velocity, fine. So this is the velocity of this particular liquid molecule, okay. So each molecule, all the liquid molecules, whoever had reached this particular section A at time t equal to 0 will take time, by the time it is t, it will reach here, isn't it? That means all these molecules have a velocity of what? V. So let's consider that velocity of flow is V. And I again want to mention that this is a streamline flow, okay. We cannot apply streamline flow, I have already explained. So streamline flow, maybe I have not explained, but streamline flow, that I want to say that the liquid molecules are always having a uniform velocity, and their velocities never change with respect to time, fine. So all the molecules will be having the same velocity. So if some molecule is following this molecule, if it is having V, this molecule is also going to have V. If some other molecule is coming, this molecule is also going to travel with a velocity V. That is the meaning of streamline flow. So all the physics theory, fluid dynamics theories can be applied to only streamline flow. We cannot apply these rules to turbulent flow. So again I will tell you that streamline flow means all the molecules are moving with the same velocity, okay. So if this molecule is moving with a velocity v, this is also going to follow the velocity v, this is also going to follow the velocity v. So velocity of flow is now what? Small v, fine. So can I write L equal to v into t? Okay, so now the thing is that now if I ask you that what is the exact volume of water that has entered this tube through section A in time t, okay, I will write it. Volume of fluid that has entered the tube as shown in figure, okay, through section A in time t is equal to, okay, what is my question? What is the volume of water that has entered, okay, volume of liquid or fluid that has entered this tube through section A in time t? So in time t, how much it can travel? this much only. That means in time t it will cover up to this. So this is the volume of water that has entered, isn't it? Now if I ask you what is the volume of this region, then what will be that? Area is how much? A. And what is the distance? L. So volume is A into L. Okay. Now A is fine. L means what? V into T, that we have already obtained here, isn't it? So that means A, V and T. So this is the volume that has entered, volume in time T. Okay. So if I ask you what is the volume per second, that will be what? AVT by T. So that is nothing but equal to what? A into V. Okay. So this is the volume of water or liquid or fluid entering this particular tube per second. Okay. So this particular thing is called a rate of flow of fluid. Okay. So that thing is called A into V. That means rate of flow of fluid through any tube is basically equal, is a multiplication or product of area of cross section of the tube by velocity of flow. Understood? Okay, so this is a very important relation, that what is the rate of flow of a fluid, that is equal to area of cross section of the tube into velocity of the flow. So this note I have already provided. So this is a very important definition, as well as this concept is required in all other derivation that we are going to do in future.